We've already come across several ways of detecting radiation. Henri Becquerel found out accidentally that radiation fogged film when he was doing another kind of experiment altogether. Ernest Marsden spent hours in a darkened room staring through a microscope at a fluorescent screen counting tiny flashes, and the actual paths that individual alpha or beta particles take can be detected by the trails of tiny droplets they leave behind as they shoot through a cloud chamber. But the best known type of radiation detector is called a Geiger counter. The Geiger counter is made up of two parts: a tube, which detects radiation and turns it into an electrical signal, and a counter, which keeps track of the number of particles detected. The detection part is called a Geiger-Muller tube, named after Rutherford's colleague Hans Geiger, who invented it in 1908, and his collaborator Walter Müller, who helped him refine the design much later. As you move the tube around a radioactive source, you can see it detects radiation in all directions. And as you move it closer and further away, the reading goes up and down. The GM tube can only detect the small fraction of the radiation that actually hits it. The rest spreads out and is never counted. So you can use the GM tube to find out how radiation changes with, for example, distance, or shielding, but you can't use it to work out the total amount of radiation being given off. The Geiger-Muller tube works by detecting ionization. The radiation enters through the end of the tube through a very thin screen, which even lets alpha particles pass through it. Each alpha particle, say, causes ionizations of the low pressure gas inside the tube. A high voltage accelerates the electrons released and causes a cascade of further ionizations. There are enough free electrons now for a small current to flow, and the detector registers a count. GM tubes are good at detecting individual alpha and beta particles, but they're not so good at detecting gamma radiation. And this is because gamma rays produce very little ionization in a gas. To detect gamma, it can help to turn the GM tube on its side. A gamma ray can knock an electron off the metal wall of the GM tube and cause an ion cascade, and hence a count.